Hello, welcome to Unplugged. Today we're diving deep into the world of NoSQL databases.
It's a fascinating area.
Yeah, absolutely. We've looked at a whole range of stuff for you, comparing different NoSQL types, security essentials, the ideas behind consistency, scaling strategies, and also a really interesting look at SpiceDB.
hmm
Our mission really is to get a handle on where NoSQL is heading, the key things to consider, and especially understand what SpiceD brings to the table, particularly with permissions.
Yeah, and it's worth remembering, why NoSQL even emerged. Relational databases were king for so long, right?
Right. The standard
But then applications started needing to handle, well, just much more varied data types and huge traffic spikes. The old models just weren't flexible enough.
became a bottleneck.
Exactly.
Yeah.
So NoSQL was born out of that need for flexibility and serious scalability. You have a fundamental shift in thinking about data management, especially when things are spread out.
Totally. And it's not just one thing, is it? There's so many different types of NoSQL out there.
Oh, definitely not one size fits all. The landscape is pretty diverse. Each type really has its own strengths.
Like what?
Well, you've got document databases. Think MongoDB, Couchbase. They store data in these JSON-like documents, which is super flexible, great for, say, content management, where every item might be slightly different.
Okay. Yeah, I can see that.
Then there are key value stores. Redis, DynamoDB are big names here, all about speed. Simple P, simple value, often in memory. Lightning fast for caching or maybe user session data.
Right. Speed is key there.
hmm And you also have column family stores, graph databases. They tackle more specific problems like managing huge, sparse data sets or mapping complex relationships. The choice really hinges on what problem you're actually solving.
So, dealing with those huge data sets you mentioned, scalability must be absolutely central. How do NoSQL systems cope when things get really big and busy?
Yeah, scalability is like baked into the NoSQL philosophy. Often it's the main reason people switch.
Makes
You've got two main approaches. Vertical scaling, that's just beefing up one server. More power, more memory.
the traditional way, sort of.
Kind of, yeah. But horizontal scaling is generally more common and more powerful in the NoSQL world. That's where you add more servers, more machines, and spread the load across them.
Like a team effort instead of one strong man.
Exactly. A team of workers all pitching in.
But how do you manage that team? How do you make horizontal scaling actually work well?
That's where some smart patterns come in. Load balancing is crucial. It's like a traffic director, spreading requests evenly so no single server gets swamped.
Okay.
Caching is huge, too. Storings frequently use data closer to the app. Maybe using something like Redis, again, takes a massive load off the database and speeds things up.
Right, less hitting the main database.
Precisely. Then there's database sharding. That's more complex, breaking your database into smaller pieces or shards and spreading those across servers, like splitting a giant phone book.
Gotcha. Makes lookup faster.
Yeah. And of course, in the cloud, you often have auto-scaling, which just handles adding or removing resources automatically based on the current demand. Takes away some of the manual headache.
Sounds like a lot to juggle. How do you even know if it's working? What do you measure?
Good question. You're looking at core performance metrics, query response time, how fast does it answer, throughput, how many requests per second, latency, the delay.
The lag.
Exactly. And you're also constantly watching resource usage, CPU, memory, disk I/O on your servers. Critically, you need to test this under different conditions.
Oh, right. Not just average load.
No way. You need read-heavy loads, write-heavy loads, mixed traffic, sometimes even analytical queries, and test with different data sizes, too. You need realistic benchmarks.
Are there tools for that?
Yeah, tools like Apache JMeter or YCSB, that's the Yahoo Cloud Serving benchmark, are pretty standard for putting these systems through their paces.
Okay. So with all this data potentially spread everywhere, security must be a massive concern. How do you keep it all locked down?
Oh, absolutely critical. Security in NoSQL needs a layered defense. A basic fundamental step is separating your database servers from your web servers, network-wise.
Why is that?
Well, if your web server gets compromised, the attacker doesn't immediately have direct access to your database backend. It contains the breach, somewhat.
Ah, okay. An extra barrier.
Exactly. Database firewalls are another layer. These could be specialized appliances or just using the firewall capabilities built into the operating system to tightly control who can even talk to the database over the network.
And what about controlling who logs into the database?
That's crucial too. You need strict control over user access. The principle of least privilege is key here,
Meaning?
meaning users get only the permissions they absolutely need to do their job and ideally only for the time they need them. Things like temporary access or using privileged access management PAM software help manage and audit this, especially for admins.
Right. Minimize the potential damage if an account is compromised.
Precisely. And for development and testing, you absolutely need separate environments. Critically, use synthetic or properly anonymized data there.
Yeah.
Never use real production data for testing if you can avoid it.
That seems obvious, but probably gets missed sometimes.
It does. Other big things are continuous auditing and monitoring. You need logs of everything, logins, failed logins, who's trying to elevate privileges, unusual data access patterns.
So you can spot trouble early.
Yeah, setting up alerts for suspicious stuff using database activity monitoring or DAM tools is really important. And of course, regular security hygiene, patching systems, running vulnerability scans, doing penetration tests to find weaknesses before attackers do.
And the data itself, any specific practices there?
Definitely. Think about minimizing the sensitive data you store in the first place. Do you really need it? Eliminate redundant copies. Try to dissociate personally identifiable information, PII, if possible. And encryption is non-negotiable.
Encrypting it where?
Both when it's stored on disk encryption at rest and when it's moving over the network encryption in transit. Some advanced systems even work on encryption in use, but at rest and in transit are the baseline.
Okay, that's a lot on security. Now, something often talked about with databases is ACID, atomicity, consistency, isolation, durability. How does that fit with NoSQL?
Right, ACID. Those properties are the bedrock of reliable transactions in traditional databases. Atomicity, all or nothing for a transaction. Consistency, database stays valid. Isolation, concurrent transactions don't mess each other up. Durability, once it's saved, it stays saved, even if the system crashes.
The gold standard for reliability, you could say.
For many years, yes. Relational databases really prioritize strong ACID guarantees, but many NoSQL systems, especially the distributed ones designed for massive scale and uptime, often make, well, let's say different trade-offs, particularly around consistency.
They relax the rules a bit.
Sometimes, yeah, to gain higher availability or better performance when network partitions happen. This whole area ties into the CMP theorem, the idea that in a distributed system, you can't perfectly guarantee consistency, availability, and partition tolerance all at once. You often have to choose which two to prioritize most heavily.
So if you have data scattered across many machines in a NoSQL setup, keeping it consistent must be tough.
It's definitely one of the major challenges. While strong ACID consistency might be relaxed, it doesn't mean consistency goes out the window. There's another model you sometimes hear about called BASE.
Base.
Yeah, basically available, soft state, eventually consistent. It describes systems that prioritize being available even if parts of the network fail, but accept that data might be temporarily inconsistent across replicas, though it will eventually catch up.
So eventual consistency.
Right. But even systems leaning towards base often have mechanisms to manage consistency. Transaction management is getting better in distributed systems. Consensus algorithms like Raft, which systems like TiDB use for reliable replication, ensure nodes agree on changes. And there are tools to actually check for inconsistencies, like TiDB has an ADmin check table command.
Interesting. Okay, this feels like a good point to bring in SpiceDB. You mentioned it earlier. It's described as a centralized authorization service. After all this talk about distribution, centralizing sounds, different, what's the idea there?
Yeah, it's a really interesting approach. SpiceDB is inspired by Google's internal system, Zanzibar, and it's tackling the real hitters of managing permissions authorization in modern, complex apps.
Bye to headaches.
Think about it. You keep adding features, maybe complex sharing rules. Your authorization logic gets tangled up everywhere in your code.
Yeah.
It becomes hard to understand, hard to change safely.
Nightmare fuel for developers.
Totally. And if your users are global, checking permissions against a database far away adds lag, latency. Refactoring authorization is slow and risky. If you have microservices, each might try to do its own authorization, leading to duplication and subtle inconsistencies.
Okay, I see the pain points.
So SpiceDB aims to fix this by offering a single, consistent, fast place to manage all your authorization logic.
So instead of my app figuring out, can Alice edit this doc, it just asks SpiceDB.
Exactly that. Your app authenticates Alice, knows who she is, then asks SpiceDB, check permission, can Alice subject edit, actions, document, resource. SpiceDB looks at the rules and relationships it knows about and gives back a simple yes or no.
Centralizes all that tricky logic.
Precisely. Makes it easier to manage, easier to audit, easier to update without breaking things across 10 different services.
And it uses this relationship-based access control ReBAC. How does that actually work inside SpiceDB?
So with ReBAC, the core idea isn't just assigning permissions directly, like Alice gets edit permission. Instead, you define relationships between things.
Relationships like,
Like Alice is the owner of document.123, or Bob is a member of project.alpha. The permissions then flow from those relationships based on rules you define in SpiceDB.
so the rule might be owners can edit.
Exactly. Or members of a project can view all documents within it. It models how things are connected, which often maps more naturally to real-world authorization needs.
That does sound cleaner. What are the key SpiceDB features built on that ReBAC idea?
Well, first you define a schema. This explicitly lists your resource types like document, folder, your subject types, user, group, and the possible relationships between them, owner, viewer, editor, parent.
A blueprint for your permissions.
Right. And you can test this schema in their Playground tool, which is pretty neat. A huge feature is permission inheritance.
You mentioned that, so if I'm in a group,
Yeah, if a group has viewer access to a folder and you're a member of that group, you automatically inherit viewer permission on everything inside that folder, unless another rule overrides it. Super powerful for managing access efficiently.
definitely sounds scalable. What else?
SpiceDB adds nuance with things called caveats. These let you attach conditions to relationships, sort of like attribute-based access control, ABAC, but still grounded in relationships.
Can you give an example?
Sure, you might have a relationship user.charlie is a reader of article.premium, but you add a caveat to that relationship with caveat has valid subscription true. So Charlie only gets access if the caveat condition checked at runtime is also true.
So it checks the relationship and an attribute like subscription status. Clever.
Yeah, it blends the models. They also explicitly support hybrid models. You can combine hierarchical relationships, like folders containing documents, with direct permissions and conditional logic using these caveats.
So quite flexible in defining complex rules.
Very. And they have operators to combine conditions. You can use multiple intersection, meaning multiple relationships must hold true. Like you must be a manager NED in the finance group.
Okay.
Or union, any one of several conditions is enough. And exclusion, to explicitly deny access even if another rule would grant it.
Exclusion seems important for exceptions.
It is. And caveats, again, allow for runtime conditions, like that temporary access example, a relationship that's only valid if current time expiration time.
Right. The time-limited access.
And performance is a big focus, too. SpiceDB caches results of internal subproblems or repeated checks to keep authorization lookups really fast so it doesn't slow down your applications.
Okay, so how do you actually run this thing? How do you deploy SpiceDB?
They provide official container images supporting standard AMD 64 and also ARM 64 architectures, which is nice. So Docker or similar container runtimes work.
Pretty standard deployment then.
Yeah. And if you're using Kubernetes, which many are for production systems, they have a SpiceDB operator that helps automate deployment, configuration, scaling, and management of a SpiceDB cluster.
Makes sense for production. How do apps talk to it?
They provide client libraries for various languages, Go, Python, Java, etc. So your application code can easily make those check permission calls. There's also a command line tool called NurSpiced for managing schemas, relationships, and testing things out.
Okay. And given it's meant for these big distributed systems, how does SpiceDB itself stay available and scale?
Well, being based on Zanzibar principles means it's designed for scale from the ground up scale in terms of traffic, geographic distribution, number of features, and development speed.
Built for the load.
Exactly. While our material didn't dive into the absolute specifics of its internal replication, the general principles for reliable distributed systems apply. You'd expect redundancy, multiple running instances so one can fail without outage and replication, copying the authorization data across multiple machines or data centers for fault tolerance and availability. Keeping that replicated data consistent is, of course, a challenge they need to solve, likely using consensus algorithms like we discussed earlier.
Right, tying back to consistency. Okay, one last clarification. Authentication versus authorization. Where does SpiceDB sit?
Crucial distinction. Authentication is who is this user? Verifying identity, passwords, tokens, biometrics, whatever.
Proving you are who you say you are.
Right. Authorization is what is this user allowed to do?
Yeah.
Given that we know who they are, do they have permission for this specific action on this specific thing?
Okay.
SpiceDB is purely focused on authorization. It assumes something else has already handled authentication. Your app says, I've authenticated user X. Now tell me, SpiceDB, can user X delete file Y?
Got it. Handles the what, not the who.
Precisely.
Okay, so wrapping up this deep dive, where does this leave us?
Well, we've seen NoSQL databases offer vital flexibility and scale for today's apps, but managing them involves real challenges: security, performance tuning, ensuring consistency, especially when data is spread out.
Hmm.
And SpiceDB emerges as a really focused solution for one big piece of that puzzle: authorization. It offers this centralized ReBA approach, enhanced with features like caveats and flexible modeling, aiming to make permissions management more robust, more auditable, and maybe even speed up development by untangling that logic from individual services.
It's a compelling approach. And it really leaves you wondering, doesn't it? As applications get even more distributed, more features, more complex interactions, how will centralized services like SpiceDB evolve? How will they shape the way we build secure software and how fast we can do it?
Yeah.
Definitely something to keep an eye on.
For sure. It's a dynamic space.
Thanks for listening to Unplugged. Stay tuned for our next deep dive.